Hey, in this video we're going to go over definite integrals. So I'm going to put the link to my integrals video in the description because it's almost basically the same thing. If you know how to do that, you almost know how to do this. So watch that before you watch this and let's get started. First, one thing you have to do is for a definite integral, if I have the integral of 2x with respect to x, what you would have is something called as bounds. These bounds, you probably already know what they mean, but imagine a function kind of like this, and you have a function. If you have a bound, you're basically finding the integral from this to this. You're finding the integral over this space over here. So you have a bound. It's not an open. You have boundaries on either side to block where your integral is going to end and start. And these boundaries are going to be written on this symbol over here. So if I have a 1 and 2, this is said to be the integral of 2x with respect to x from 1 to 2. You go from bottom to top. That's how you find a definite integral. What is that going to look like? Okay, nice question. First, what is the integral of 2x? That is equal to x squared. You have to find that like you would for any other integral that you've ever seen in your life. After that, the one extra step you have to do is find what the value of this is from 1 to 2. So I'm going to put this line over here. I'm going to say from 1 to 2. Once again, what this means is that you are finding the value of x squared from 1 to 2. And that would be equal to the top number, which is in this case is a 2, plug it into the x, you would get 2 to the power of 2, and then always subtract the bottom number plugged into x, which would be 1 to the power of 2. So let me repeat what I did. You have the bounds here, you have 2 and 1. The top bound always goes first when you are subtracting, but you plug it into x, you have that first part, and then subtract. The second part is going to be the bottom number plugged into x. And that's how you find a definite integral. Now you just want to find the value of this. 2 squared is 4, 1 squared is 1, so this is equal to 4 minus 1, which is equal to 3. So that's how you find a definite integral. Let's move on to a few more examples where they're going to get a bit more complicated. Okay, question number 1. Here we have the definite integral of x squared with respect to dx. And I know it's a definite integral because it has bounds. If you see bounds, you already know it's a definite integral. How do you find this? First you find the integral of x squared. So let's do that the way you would usually do it. Make the exponent increase by 1. So instead of x squared, you have x cubed, and divide by that new exponent. That new exponent is 3. So you just found the integral of x squared. Now you want to plug in the bounds. So you'd always put this bracket like this, and then put a line here that says you are going to find the value of x cubed over 3 from 1 to 2. That's all that is different for a definite integral. Now let's plug it in. First you plug in the 2 into x. You get 2 to the power of 3 over 3, and then you always subtract, and then put the next number into x. So 1 cubed over 3, kind of like that. So this would be 2 cubed is 8, so you'd have 8 over 3, and then minus 1 cubed is 1, you would have minus 1 over 3, which is equal to 8 minus 1 is 7 over 3, and you are done. You just found a definite integral of this question. Question number 2, same thing. So you have the definite integral of 3x with respect to x from 3 to 4. So if you want to find that, what is the integral of 3x first? Right here we have an exponent of 1, so make it have an exponent of 2 because we always increase the exponent by 1. And then put the 3 there because that was already there. We're not going to change anything. You just copy paste that there. And then divide by that new exponent. That new exponent is going to be a 2, so over 2. And that's it. And now you want to find the value of this at the boundaries. So you would put a bracket around it, and then a line, and then say this is from 3 to 4. Put this in, so plug 4 into this, you get 3 times 4 squared over 2 minus, and then put the 3 into the x, you get 3 times 3 squared over 2. Put this in a calculator, so 3 times 4 squared is 16, so 3 times 16 divided by 2 should be 24. So this first fraction is equal to 24, and then minus the second fraction, it will be 9 times 3, 27. 27 divided by 2 is 13.5. And then once you subtract those, you should get this is equal to 10.5. And that is your definite integral. And you are done once again. Question number 3, same thing. So you have the definite integral of 1 over x squared with respect to x from 4 to 10. So this one's a tiny bit more difficult because the x is on the bottom in this case. If you get an x on the bottom, the first thing you have to do is bring it back to the top so that we have something that looks like this. For integrals in general, if it's on the bottom, you kind of get stuck. So we can change this to look like the definite integral of 4 to 10 of x to the power of negative 2 with respect to x. All I changed was 1 over x squared to be x to the power of negative 2. Now we can actually do what we do every single time. So what is the integral of x to the power of negative 2? This would be x to the power of, what's negative 2 plus 1? That would be negative 1. Don't make the mistake of writing a negative 3, because if you add 1 to negative 2, you get negative 1, not negative 3. And then this would be over the new exponent. In this case, the new exponent is a negative 1, so divided by negative 1. So you have your integral here, and then put brackets around it, like this, and then put a line, and we're going to write from 4 to 10. Pretty simple. So now, let's actually make this look a tiny bit nicer. If you have x to the power of negative 1 divided by negative 1, you basically have negative of 1 over x. Those are the exact same, and we're going to copy our brackets again, because we didn't do anything with that yet. So from 4 to 10. After that, you just have to plug it in. So first plug in the 10. You get negative 1 over 10, obviously, because all you have to do is put the 10 on the bottom. And then minus, in this case, you would put the 4 in. It would be negative 1 over 4. Okay, and then after that, you do put it in a calculator, or we could simplify a bit first. This would look like negative 1 over 10 plus 1 over 4. Put that in a calculator once again, so 1 over 4 minus 1 over 10. That would be 3 over 20. So that is our answer, and we are done. Okay, next question, question number 4. Same thing, once again, you have an exponent which is negative, so it's easy to make a mistake here, so just be a bit extra careful. Add 1 to this exponent, negative 7 plus 1 is negative 6. So you'd have x to the power of negative 6, and then divide by this new exponent. In this case, you would divide by negative 6, put a bracket around it, and then find the value at the boundaries. So put a line like this, and then write the boundaries are 1 and 2, so 1, 2, that's it. Now you have to plug in 2 into x. You would get 2 to the power of negative 6 over negative 6, kind of like this. And then minus, now you have to put the 1 into the x. You would get 1 to the power of negative 6 over negative 6. Put this in calculator. For the first part, we have 2 to the power of negative 6 over negative 6. And this will be equal to negative 1 over 384. So pretty small number. And then minus, this time you'd have negative, 1 to the power of negative 6 over negative 6. So this would be equal to 1 over negative 6. So 1, kind of like that. And then once again, do something to the signs. If you have two negatives, it becomes a positive. So you'd have negative 1 over 384 plus 1 over 6. Once again, put this in a calculator just to find the final answer. So you get 1384. Okay, you get 21 over 128. And we are done. That's pretty much it. Next question, question number 5. This one is a bit new. You probably have not seen it before. But same thing. So what is the integral of cosine x? This one has to be memorized. There's no other way around it. But you have to know the derivative of this to know the integral. So the integral of cosine x is equal to sine x only because the derivative of sine x is cosine x. So they're backwards. They're vice versa. Okay, so after you find the integral, plug the points in once again. Nothing changes. So put a bracket around it. Put a line. We want to go from 0 to pi over 2. And obviously these are in radians because you have pi over 2 on top. So this would be equal to sine. First plug in the pi over 2. So sine of pi over 2 minus sine of 0. Because you plug in the 0 when you subtract the next number. So what that would give you is sine of pi over 2 is 1. Sine of 0 is 0. 1 minus 0 is 1. That's it. We are done. Okay, question number 6. For this question, you have to memorize it once again. But the integral of 1 over x is equal to ln x. There's no other way of knowing how to do this because you have to know that the derivative of ln x is 1 over x. So they're kind of vice versa, like I said. But once again, you have to memorize this. There's no other way around it. Kind of like sine and cosine. The same exact thing happens here. And then, after you know that the integral is ln x, you would put the bracket like we always do. Kind of like this. And then put a line, once again, like we always do. And then write 1 and e. So after that, plug in the e into x first. You would have ln of e. And then minus ln of 1. put the e first and then put the 1, and between them you have a subtraction sign like all the time. Okay, after that, now you have to actually solve the answer. Ln of e, you can put this in a calculator, or you could already know it. This is equal to 1. Ln of 1 is equal to 0. So minus 0, this is equal to 1. And we are done. So this was pretty simple. Nothing here was pretty difficult, but it's easy to make mistakes since the questions are a tiny bit confusing and a tiny bit long in the sense of you have a lot of things to do at the same time. But yeah, so that's it for this video. If it helped you, leave a like because it helps me. And yeah, hopefully I'll see you in the next video. So yeah, that's it.